We're going to extend what we did in our last lesson, talking about, again, rigid motions. We already know what those are by now. Preserve shape and size, just I'll review for you here on the front page. Isometric transformations, rotations, translations, dilations, not dilations, wow, rotations, translations, reflections, okay? Those are our isometric transformations, and those are all rigid motions. Rigid motions, boom, 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 right? Boom, boom, boom. They're all rigid, okay? You can't change the size and shape. To be a rigid motion, it's got to be same size and shape. All right, so two figures, and we should know this already, two figures are congruent if and only if one can be mapped onto the other by one or more rigid motions. So it could be one reflection, it could be 3, 4, 5 reflections, flip, 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 flip. It could be slide all over the place. It could be flip and then slide. It could be flip, rotate, slide. We've done all these, right? No matter what, as long as it's rigid motions, you're going to have congruent figures. Quadrilateral, hexagon, triangle, it doesn't matter, all right? So we start here with a quadrilateral, and we show the different congruences. We were talking about correspondences, right? Correspondence in our last lesson, how the angles correspond, right? So see how the different letters are different colors. Now on your paper, it's just different shades of gray, right? But here we have colors. A is black, M is black, B is red, N is red, C is blue, O is blue, D is green, P is green. Purposely. Why? Those are the corresponding angles. Those are corresponding vertices. Therefore, they'll give you the corresponding angles. So angle A will be congruent to angle M if you were to draw these two quadrilaterals. Angle A would be congruent to angle M. Angle B congruent to angle N. Got it? AB, black, red. AB will be congruent to MN, black, red. See, black, red will match up with black, red. AB, MN. Okay? Red, blue. Red, blue. BC, NO. Side BC will be congruent to side NO. I think you get the point. I hope you get the point. All right. So let's do some examples here. Determine the congruent sides and angles from the congruent statement. So if I tell you, I'm not even going to give you a picture, no diagram, triangle AGR is congruent to triangle HGM, you should now be able to tell me that angle A, I better leave some room, angle A is congruent to angle H. Why? Because A is written first. A is written first and H is written first. They correspond. Angle G is congruent to angle J. Angle R would be congruent to angle M. That must be true if the triangles are congruent, and they're telling us they are. First letter, second letter, AG. First letter, second letter must be congruent to first letter, second letter, HJ. So side AG, whatever triangle AGR is, and wherever triangle HJM is on the graph or just in the plane, it doesn't matter, it doesn't have to be on a graph, wherever they are, AG will be the same length as HJ because of the way it's written on here. That's very important. I know this seems like really easy, but it's important because we can't move into triangle congruence until we understand this fully. GR would be congruent to JM. And then first last, AR would be congruent to HM. Why don't you pause the video and see if you could try the next one. All right? We won't even do the quadrilateral. It's just too much, right? We're just going to skip this one because I think we get it. If we could do triangles, we could do quadrilaterals. All right? Did you try it? You should have angle A congruent to angle R. You should have angle B congruent to angle T. And you should have angle C congruent to angle Y. All right? So that means AB must be congruent to RT BC must be congruent to side TY, and side AC must be congruent to side RY. Why? First letter, last letter, first letter, last letter. The way it's written is very important. CPCFC. Corresponding parts of congruent figures are congruent. That's basically what we just talked about. The corresponding parts, the A and the H, the G and the J, right? The corresponding parts of those congruent figures are congruent. So showing you pictures here, just showing you examples here. Here's a translation, slide over, see, QRLV, okay? Or not, that's a U, UV, QR and UV, right? Okay, so you could see how it slides over. This one's a rotation, right? This one's a reflection. You could see it's the same size and same shape. That's just meant for you to reference, okay? Example 2. Quadrilateral ABCD. Oop. Quadrilateral, I wanted to go there for a second, okay. Yeah. All right, quadrilateral ABCD is congruent to quadrilateral HJKL. Complete the following congruent statements. Angle A must be congruent to what? Well, it's the first letter, so it must be the first letter, H. JK must be congruent to middle two letters, B, C. Angle L, last letter. Angle D and DA, last letter, first letter, L, last letter, first letter, H, LH. Okay, that's a D. Doesn't look like a D. All right. Pentagon ABCDE is congruent to pentagon HJKLP. All right. Complete the following congruent statements. B, I don't even need the pictures, but they gave me the pictures in case I want to look. But I already know it's B, second letter, J, second letter. Okay, is that J? J, so it must be B. Okay. KL, third and fourth letter, CD. And DE is the last two letters, LP. You're like, wow, this is so easy. It is, but it's so important, guys. It really is. Without understanding this, we're going to be in trouble when we get to our triangle proofs. Triangle ABC is congruent to another triangle, provided is some information about the two triangles. AB is congruent to LP, and CA is congruent to ML. From this information, determine the triangle congruent statement. All right, so just match it up. Here's AB, right? Here's AB, that's got to be the same as LP, so LP must go first. And then, of course, what's left over? M. CA, right? Okay, so CA, last first, right? ML, this must be an M. All right, LPM. Are quad QRST and quad PLKJ congruent? Are those two congruent? Okay, what quadrilaterals are you talking about here? What the heck did I do? All right, so I don't have anything. All right, so we're going to cross that off. I don't know what happened there. All right, so we don't have those quadrilaterals. All right, here we go. Example 3. Name the transformation or sequence of transformations that maps one figure onto the other. Then complete the congruent statement. All right, so what happened here? Looks like it is a rotation. Looks like it's a rotation. If you're not sure, talk to me in class tomorrow and I'll explain it a little bit better for you. But basically, I could tell you right now, turn your paper upside down. The ABC, isn't it in the same position where the KHL is? Okay, so it's exactly the same there. And triangle ABC, all right, so the A goes to K. So that's going to go first. The B goes to L. Okay, so the B goes to L, and the C rotates to H. So then the H goes last. So it's KLH. What is this transformation? Well, it looks like it just slid up and to the right, correct? Right? So it's a translation. And ABCD, well, A slid to P, so P. B slid to Y. Is that a Y or a V? Looks like a Y maybe. PY. C went to R. And then D went to L. So it's quad PYRL. That's how we would name that. So in example 4, you're given two figures, and what you have to do here is you have to come up with a sequence of rigid motions or isometric transformations to say how did you get from the first one to the second one. So these are a little tricky, and they take some practice, but I'm going to show you how to do this one. This one here, triangle ABC, how do you get from triangle ABC to this one? Because it's not one thing. If you just rotate, it's not going to get there. If you just reflect, it's not going to get there. You had to do two things. So I already know what it is, so I'm just going to kind of show you what happened, and then you got to try and come up with it on your own next time. But anyways, this one here, it actually rotated. It rotated from quadrant 2 into quadrant 1. If it rotates, see it's like this, and it rotates like this, all right? And then I'm going to show you what happens after it rotates. So see how you remember it's opposite directions? It's negative 5, 2. So we're going to go 2, 5. 1, 2, 3, 4, 5. All right. And then this one is, that's what? C prime. Okay. And then A prime is negative 5, 8. So we're going to go 8, 5. 8, 5. And we should already know how to do this. So that's A prime. And then B is 2, 8, 2, left 2, up 8. So it's going to be over 8, up 2. So there's the rotation. Because we did rotations before. That's not new, right? So that's a rotation, negative 90. Why negative 90? It went clockwise. Okay. See that? So now there's my rotation, negative 90. And look at, now from there to there, you could tell it just flipped over the x-axis. That's easy, right? So what happened here? There was a reflection, negative 90, then a reflection over the x-axis. Okay? Reflection, negative 90, then a reflection, rotation, negative 90, and about the origin. I should put the origin, right? O, comma, negative 90, that's the proper way to write it. Rotation, then reflection, okay? So state the sequence of, there is the sequence right there. If I want to write it in function notation, though, you would say it was a reflection, x-axis, of a rotation about the origin, negative 90 degrees, of triangle ABC. You just need two parentheses because there was only two things, and that would equal triangle, triangle A went to Z, so Z, YR. ZYR. So they gave it to you right here. All right, so there's the function. Here's the description of what you did, and here's the function notation of how you would write it. And then, is quadrilateral QRST congruent to quadrilateral PLKJ? PLKJ. If so, state the sequence of isometric transformations that map one onto the other. Okay, so what happened there? So we have this one here. We have, it looks like a reflection. So it looks like if we reflect it over, because it's going, it's pointed up now, we need it to be pointed down, so that's got to be a reflection. Let's reflect over the x-axis and see what that does. So 6, so it'll be right here. All right, and then that one would be right there, and then that one would be right there, and then that one is 5, so we're going to go down 5 right there. There we go. See, now look at it. It's almost the same. It's going the same way. It's going the same way, right? It's just slid now. So after we reflect it, right, then slide it. So first we did a reflection x-axis. Then translation of what? Translation, so this one goes, you had to go right 1, 2, 3, 4, 5, 6. We have to go right 6 and down 3. 1, 2, 3. So 6, negative 3. Okay, translation 6, negative 3. That's the vector. Okay, the vector goes 6, negative 3. Each of these points, look, over 6, 1, 2, 3, 4, 5, 6, and down 3, 1, 2, 3. Each of these points goes over 6 and down 3. So there it is. In function notation, it would be a translation. Vector 6, negative 3. Okay, of a reflection x-axis of quad QRST, and then parenthesis, and that would equal quad PLKJ. All right, and there it is. So there's the sequence, and there's the function notation. Okay, and we are going to move into our group work for tomorrow, and I will see you